Welcome back to our next unit. This unit is over the periodic table, and we're actually going to look at the periodic table itself to figure out why does it have the funny shape that it does. And we're going to look a deeper dive into the different elements and some of their different characteristics. We're going to use these characteristics to define some of the naming properties next unit, so everything's going to keep building upon one another as we go through. So we're going to use a little bit of the atoms unit, and then we're going to use these two units in the next one with your periodic table. So as we look at the periodic table, it is made up of elements. So this slide you're going to want to go back to when you are looking at the actual PowerPoint, and you're going to want to play this song. It's just a fun song. We actually started my high school chemistry class every single day. He had it on a record, and he played it on a record player. But it is, like I said, the element song. Now, while I am talking about your notes, you do have the PowerPoint. It's also in Google Slides, so whichever one works best for you, in the Schoology folder. And then you also have the note guide as well. Now, with that note guide, I highly recommend you writing down your notes as you're going through the units. That's going to help you to retain the information a little bit better because, again, chemistry does keep building on itself, and you're going to want some of these notes second semester even. So I would suggest writing these down as you're going and keeping them throughout the year because, like I said, chemistry keeps building on each other, and sometimes you need to refer back to things throughout the year. Now, the periodic table, this whole unit, it has a set shape, but it doesn't have to have that shape. These are some different periodic tables that people have made over the years using the same methodology that the guy named Mendeleev used. So these different periodic tables looks at some of the different characteristics and properties of the elements itself, but with the characteristics, they're just arranged in a different way. So this one uses a circle type shape. This one uses more like a honeycomb. This one uses triangles instead of squares. On the next slide, this Mayan periodic table, I actually have one that somebody built and I purchased, but you have the different elements on the periodic table, and everything is built upon one another, and as it builds upon one another, you have the different blocks. So this one says 1s, so this is 1s, 1, 2. This is 2s, 1 and 2. And then here we've got the P block that we add on to it. So you can see the S block in the middle and then the P block around it. So it just uses different characteristics to actually build out a periodic table. When all the elements are all arranged, they all have similar characteristics when they're in a line like this, even though it's 3D. You've got the galaxy periodic table here that all the elements and all these different arms all have similar characteristics as well. So looking at the periodic table itself, it doesn't have to be arranged in boxes and squares and nice and neat and pretty. This one I really like. It has the different families. We talked a little bit about the like the D block, which is actually called the transition metals. All of these through here are all your transition metals. Your F block is up here. And then here in this big swoop, you actually have your S and your P block, which are your valence electrons. But then all these elements have similar characteristics when they're lined out. So we didn't have to use the shape that we did. It was just one guy that ended up getting the credit for the periodic table. And his name is Mendeleev. Now, to get to a point that we're actually looking at Mendeleev, we need to look at a few other people first. And this first guy is Antoine Lavoisier. He is not on your test. You do not need to know him, but it doesn't feel right not mentioning him because he actually did a lot of work. And he was the first one to actually take all of the elements and write them down. We didn't really have a good list of the elements at that time, and technology was getting better, which is kind of weird to think about technology in the 1700s, but technology was getting better, and we were starting to identify different elements here and there, and we were figuring out things like air isn't an element. Air was actually a mixture of elements put together. It's actually compounds put together that we found out today, but we kind of never had a good solid list of these are the elements that we know of as of today, and he was able to remove and add things as we found them in nature. So at that time we knew of 33 elements. Some of them now have been discredited and not all of them, but for the most part we do have those being identified as 33. Now 100 years later, 1870, actually 170 years later, I guess, we had about 70 elements. We about doubled how many elements we found out about. Again, we had technology getting better. We had different ways of identifying what is an element versus what is a compound. So as that chemistry kind of exploded in that time, we were able to find new elements throughout history. So the first person that really gets credit for doing anything on the periodic table, his name is John Newland. Again, he's not even on your test, so you don't have to worry about him. But John Newland was the first one that really started to realize that there are patterns with the elements. So what he did first was, we knew about the atomic mass. The atomic mass at that time was a whole number. It didn't have any isotopes. Those hadn't been discovered yet. But he took all of the elements and he wrote them down on cards. And as he wrote down each element on a different card, so we said, this one is lithium and this one is magnesium. And he actually took all of these different cards and he lined them out one by one. And as he lined them out by increasing mass, he realized that every 8th element, there was a repeating pattern. So 1 through 8, and then you have 9 through 16, 17, I guess. But each element had a repeating pattern by eighths. So he called this the Law of Octaves. Again, you've got a video here that you're going to want to watch. But he called it the Law of Octaves. And with that Law of Octaves, it kind of stalled out. He didn't quite know what to do with it after that. And that kind of led the way for Dmitri Mendeleev, this guy here. Dmitri Mendeleev was a Russian chemist, and he was looking at the periodic table as well. And as he was looking at his periodic table, he started to realize that we have these repeating patterns. Now this guy, Newland, and this guy, Mendeleev, lived on 2 different sides of the same continent. Well, I guess 2 different continents, really, because Mendeleev was Russian. But they started to realize the same thing, kind of at the same time. But Mendeleev took his one step further. Mendeleev realized that when we take the elements and we write them down by increasing atomic mass, you have repeating patterns. So this is Mendeleev's periodic table. This is Russian, so you probably cannot read that unless you took Russian. But we have the different elements kind of lined out, and these numbers that we have here are all actually the increasing atomic mass. Again, we didn't know about protons yet. We only knew about the mass. And as we look at this, I don't think I can make this bigger. Oh yeah, I can. So we have, like, lithium here is 7, beryllium is 9, boron is 11, carbon's 12, nitrogen's 14. So as we look at these different masses, they do have repeating patterns. We don't know about that yet, sorry. We do have increasing atomic mass, but then he also placed them into these different categories, lines, and like vertical and horizontal lines, based off of repeating patterns. So this was his original work that was all written out. This one's typed up a little bit neater and nicer. But he put them into the horizontal and vertical columns based off of their their chemical properties. So he wanted to make sure that if they're all in a line this way or all in a line this way, that they're going to have similar characteristics to one another. So maybe they all react with water similarly, or maybe they all react with oxygen similarly, or maybe they don't react with anything at all. So he wanted to make sure that they had these same properties when they're all in a line together, whether that's horizontal or it's vertical. Now, when he did this, his kind of whoa moment was the fact that he left 3 open spaces on his periodic table. I'm going to go back a couple slides. And when you look at his periodic table, he left question marks right here, but he said that it's going to have a mass of 68. He left a question mark here and said it has a mass of 70. And he left a question mark here and he said it had a mass of 45. Now, he didn't know that there was actually anything in that spot. He was making estimations at that point. And he said, you know what? We're going to discover an element one day, and it's going to plug into this spot, and it's going to have these masses. So he's making pretty bold at a loss for words. Bold assumptions, for the empty spaces that he left on the periodic table. Now, the big deal with this is the fact that he ended up, they ended up discovering these elements later on down the road. When they discovered the elements, they had the characteristics of what he thought they would. So he said that scandium, what we know of today, would have a metal characteristic. It would be darker in color. And with scandium here, he said it would have a mass of 45. We know today that scandium has a mass of 45. He was dead on there. And it ended up having everything that he said that they would. Now, the other elements that he ended up saying that would get discovered, he said gallium here would get discovered. He didn't call it gallium. He called it Eka aluminum. But gallium, he said, would have a very low melting point because aluminum's melting point is very low as well. He said that it would have a mass of 70. It has a mass of 70. This one right here is germanium. We didn't know about that one either. He said that it would have a pretty low melting point, but it would be higher than gallium. He said that it would be very silver and shiny in color, and here it is, very silver and shiny in color. Now, he said that this mass, I think I was wrong on the mass. Gallium, he said, I don't remember, let me go back. He said gallium would have a mass of 68. I thought that was wrong. So gallium, he said, would have a mass of 68. It has a mass of 70. For this one, he said, would have a mass of 70. That's where I got the 70 in my head. It actually has a mass of 73 when it's all rounded. So he was really, really, really close for not even knowing that these things were even in the world. So scandium, gallium, and germanium, he predicted their characteristics based off of his chart, and he predicted their masses, almost. So that gave him a lot of credibility to other chemists and said, you know what, I think his periodic table actually works. Now, more justification to his periodic table, I already kind of talked about this, that they were predicted, was this guy named Moseley. And Moseley worked with Rutherford. I don't know if you remember Rutherford or not, but Rutherford was the guy that discovered the proton. And what they did was they started to figure out how many protons were in different elements. And as they discovered how many protons were in different elements, they added on the periodic table the atomic number. So with Ti, the titanium that we have here, the Ti, we didn't have that number 22 on the periodic table yet. That's the number of protons. Moseley started to, as we figured out how many protons different elements had, like, carbon. We knew that carbon then had 6 protons. So he wrote a number 6 in the box. Now the mass of carbon was 12, so that's the only identifying mass that we had. So now we had a mass of 12 and we had 6 protons. Nitrogen, we added a number 7 because it has 7 protons. It had a mass of 14. And as they started to fill out all of these different elements, protons, they realized, whoa, wait a minute. This is all following the periodic table that Mendeleev already wrote. So they added the number of protons, which they called the atomic number. And as they started to add, everything fell into place except for a few elements. Now on the periodic table that Mendeleev did, again, I'm going to go back real quick. And as we go back on the periodic table, nickel and cobalt right here both have a mass of 59. So because they both had a mass of 59, there was no distinguishing way of putting one before the other one. However, they ended up switching basically the order from what we have versus what Moseley had, or what Mendeleev had, based off of similar characteristics, because nickel was more closely related to silver and gold, and then copper, I don't know why I said copper, cobalt, I'm a way off, sorry. Nickel was closer to rhodium and iridium. Sorry, I looked down real quick. And then cobalt was more closely related to palladium and platinum based off of their color. So what Moseley ended up doing with his periodic table was he took that nickel and cobalt and switched the order because of their protons. Cobalt has 27 protons, nickel has 28. So we needed to make sure that they were swapped out on the periodic table. There was a couple other places that happened, but with the early elements, The characteristics versus the number of protons didn't quite match up, but that's because the transition metals are kind of all lumped together. So what this led to was something called periodic law. And your periodic law just states that when you have all of the elements arranged by increasing atomic number, their number of protons, you're going to have similar characteristics at regular intervals. So what that's going to do for us on the periodic table is we're going to be able to identify all of these elements in the same group on the periodic table are all going to react similarly. Same thing down here. All of these elements in this group on the periodic table are all going to react similarly when they're arranged by this periodic law. So Mendeleev originally arranged it by mass. Moseley changed up a few of the elements and arranged it by the increasing atomic number. So they both kind of led to the periodic table, but the periodic table that we use today is still called Mendeleev's periodic table.